Hello Math 30-2 and welcome back. Today we're looking at analyzing logarithmic functions. We're finally getting to log functions of our unit of exponent and log function. But before we do that, we must first look at an inverse and review what an inverse is from grade 11. So to start off, an inverse is just when our x values become y values and our y values become x values, okay? So it's when we flip our x and y values. That's it. How do we make an equation for this? We just interchange x and y in our equation and then solve for y. That's all we have to do. Another way of saying it, an inverse is also, you could say on a graph, a reflection along the line y is equal to x. That's all that an inverse is. So here's a little example. This is right here. We have my diagram and I want to find the inverse of it. The first part is sketch the inverse. Well, I take a look at one pair here. This point is 0, 4, so the inverse of that point is going to be 4, 0. Right there. This is the inverse. Okay, my next point right here, which is 2, 0, will be 0, 2. So I put this and I connect those dots and I just made my line. There's my inverse. Okay? Next part here is we have two sets of ordered pairs. What are the inverses of those pairs? Well, let's try this out. So the first one is 10, 16. So this must be switched. My x and y values are switched. So it becomes negative 16, 10. The next one is negative 10, 24. That becomes 24, negative 10. And that's it. Now it says the equation of this function that was there was this. What is the inverse of that? So first, we must switch my x and y. So we're going to start off, we have x is equal to 4 subtract 2y. Because the x and y's are switched. That's essentially what inverse is. We're switching in our inputs and our outputs. That's it. Now we solve for y, because we can't graph this in our graphing calculator, so we're just going to solve for y. And because most of the time when we look at things, we always look in terms of y. So let's start solving for y. First, I'm going to just swap these around here. Okay, so I get 2y. And y is isolated is equal to 4 minus x. Now, divide both sides by 2. So I get y is equal to 4 subtract x divided by 2. And that is my inverse. That's it. Or I could say f of x is equal to 4 subtract x divided by 2. And that's how we find my inverse. Now, here is where we get a problem. Now, if I was to find the inverse of an exponential function algebraically, how do we do that? So first, we take my equation, and I get x is equal to 2 to the y. Now we have to isolate for y. But how do I isolate for y? So there's my problem. We don't know how to isolate y. That is my difficulty. So in order to do this, we're going to have to get into something called logarithms. So logarithms are really the inverses of exponential functions. Now, if I was to graph this, and we know these are inverse of each other, it's easy to graph. The first one is 2 to the power of x. We did that before. It's just going to look like this. And now the inverse of that is we just flip all of my x and y values. So I know there's one point, there's the next point, and our next graph is going to look like this. It is also the reflection on the line y is equal to x. Okay? Let's pretend this line is y is equal to x. It's just a rough sketch. Okay? Now, right here, when x is negative 3, y is negative 3. So the x value of the y value here is going to go to x value there, because the x and y's value just switch. So we could graph it. That's not an issue. But we have to be able to know how to solve it algebraically. And how do we punch this into our calculator to graph? And that is when we need to know how to use a logarithm. The logarithm is just essentially the inverse of the exponential function. So here's an example. Y to the 2x, the inverse of it is going to be my log. Okay, y is equal to log 2x. That's it. So this is the same thing as that. That is it. So if I have y is equal to 2 to the x, the inverse is going to be just y is equal to log 2 base 2x. That is my inverse. And that's it. Okay? So that's mostly what we're going to look at today. So logs are the inverses. It is reflecting our exponential equation along the line y is equal to x. And then, or in other words, what we could say is it is interchanging the x and y values for the log, or for the exponential function. So here we go. These are just some definitions you need to know. The base is always right here. Think of and my y is equal to 2 to the power of x. This here was my base. Base is there. Base is there. Now my next part here, my argument of the logarithm is this. So that's my argument. Okay, that's my argument. This guy is there. My y is my value of the logarithm. So it's the value of the logarithm. It's the value of the exponent. Okay? So, that should be e there. So here we go. Now, I have a little, before we start off here, I have a little setup for us. So we're going to figure out how to solve for this b value here and what the b value means. Okay? So when we change the b value, what's happening? Alright? So what is happening when we change the b value? So here's our little table, and I have another table for us to look at. So when we change the b value of the log equation, here we go. So my first one is log base 3 to the x. We're changing the b value. What does that look like? It is right there. See if you can figure out what the domain is. It looks like, does it ever cross this y-intercept? What is my range for this one? Will it go on forever? What is my x-intercept, y-intercept? What is the asymptote? What is the x value when y is equal to 1? Okay? Here's my next one. This is the second one, log base 5. This is what log base 5 looks like. It's the red value. Look at how it changes from base 3. What happens? That's the same thing as saying y is equal to 5 to the x, right? That would be the inverse. What happens when you have 5 to the x? Didn't that go closer to the y-axis? And we said this is the inverse. That's interesting. Let's take a look at my next one. This is log 1/3 x. So this one here is the green one that we just graphed. Look at how that looks like. What are my domain, my range, my x-intercept, y-intercept, asymptote, and the x value? Let's take a look at my next one here. It looks like that. So that is log 1/5. That's like saying 1/5 to the power of x. What would that look like? It would be graphed like this, it would be graphed down like this, and it would look it'd be very close to my x, or to my y-axis. This one's close to my x. And the last one here isn't on the graph, but I did it anyways. Base 10. When y is 1, it's 10. That's interesting. So with all of these here, I want to see if you guys can now, you might want to pause and finish the table, if you guys can now solve for this part here. Okay? Alright. Now, how we can do these and how we punch them into our calculator if we want to graph each of those, we have to do using the log key this here. So we go y is equal to log 10x is the same thing as log x over log 10. Or we could use the natural log to do the same thing. So this could be ln x over ln 10. So if I look at it, how did I get my graphs before? I essentially just did that. I put everything in natural log. So this is the same thing as log 3x. This one here is the same as, whoops, I'll move it right there, log 5x, because the bottoms are base. This one here is the same as log 1 over 3x. This one here is the same as log base 1 over 5x, and this one here is the same as log base 10x. Pretty much exactly as what it's telling you to do here on how to graph. Okay? That's how I graphed it as well in that program. Now we're going to look at the value of a and how does it affect the graph as well. So if I take a look at these here, how does a affect the graph? Well, how did a affect the graph in my exponential function? What did it do? It's like multiplying this here by 2. Whatever value we have for x there, we multiply it by 2. So my y value is going to be twice as big. here a is equal to 1, so my y value is going to be the same. So this is really expanding it out that way. This one, negative 2, is going to flip it, because what was positive before is now going to be negative. Negative 0.5 is going to flip it and compress it, so it's going to look like that. Okay? So to graph all of these and figure out more, I'll let you guys do that by yourself. So here's just a quick review of everything that we've learned. The x-intercept is always, well, 1. Okay? The x-intercept for a log is always at 1. There is, how many y-intercepts? There is none. There is no y-intercepts. The domain is always going to be x must be greater than 0. Okay? Where x is an element of all real numbers. The range is y is always just an element of all real numbers. Okay? Now the x-axis is the vertical asymptote to which equation? Or sorry, which axis is the vertical asymptote? That's going to be my y-axis is the vertical asymptote with the equation of y, or of x is equal to 0. Okay? Now here's the next part here. We want the values of a. When a is greater than 0 and b is greater than 1, the graph in quadrant 4, so my quadrants look like this, 1, 2, 3, and 4. My graph goes from quadrant 4 to quadrant 1. Does it increase or decrease? It is going to increase. So if we're looking at this, we're saying this is greater than 1, and that's greater than 1. So it's going to go like that. It's going to go like this here. The next one is if a is greater than 0, so that's positive, and b is in between 0 and 1. Well, that's going to start going down. That's going to decrease. The next one, if a is less than 0 and b is greater than 1. Well, a is less than 0, so that means it's going to be going down, and then we're flipping it, and then b is greater than 1. Well, if b is greater than 1, it's going to stay down. It's not going to flip it again. So this is going to be a decrease. I would say the best way of looking at this would look at your b value first. Now, if b is greater than 1, we're increasing. Okay? If b is in between 0 and 1, we are decreasing. That's the main thing. Now, if a is positive, that means we don't flip it. If a is negative, we have to flip it. So this one here, we'll just look at the b, it is decreasing. Now, a is negative, so that means we must flip it. So that means it's going to be increasing. And that's it. Okay? So, here we go. Here are some examples for us. State the inverse of the following functions in the y form. Okay, so that's simple. This first one is just going to be y is equal to 3 to the x. That's my inverse. This one here is y is equal to log 8x. Okay? Here's my next one. Of the graphs below, which one represents the function a log bx? Okay? So which one could not represent that function? Well, this one right here, if we're looking at this one, this is either a is less than 0 or a is less than 0 or b is in between 0, 1, and 0, right? It's one of these two for this one here because it's going down. Okay? So it's one of those and not both. So this is true. We have an x-intercept. That's good. This one's true. We have an x-intercept. This one here, if we look at it, there is no x-intercept, no y-intercept. So this one is wrong. Number 3 cannot be of any of them, okay? Because it does not cross the x-axis. And also, our range is an element of all real numbers because it looks like it'll go forever that way. And that's everything. Hopefully you guys understood the lesson. As I see you tomorrow, we'll talk the questions together.